Before we start, sorry for my voice that a bit too different because I'm got sick now, but it's okay. Alright, let's start to the video. Imagine that you have a square that this side length is a 1 and the other side is 1. So the area of this square is 1. Now we move a little bit aside and let's check if we add rectangle with area as 1/2 and then quarter and so on until 1 over n. This leads us to a question that what if n is infinity? And then how about the area? This leads us to concept about sequence and series in mathematics. In mathematics, sequence is about list of objects that are ordered by index 1 and then index 2 and so on until some index n. By this concept, we have another concept that known as convergence, which leads us to the sequence is converge or diverge. Imagine that you have this number line. I not give explicit label of number. If we take a1 at this and then a2 at this and so on until an just like this, which all sequence here lead to specific number or object, then the sequence an is converge. And if not like this, the sequence will be diverge. And for diverge sequence, let P1 as here and then P2 here and P3 here and so on until Pn, which is placed at out of nowhere. I denote the end of the sequence as n goes to infinity for both an and bn. So we will have conclusion that a sequence is converged when n goes to infinity. The sequence lead us to a finite number. If not, the sequence will be diverged in number line concept. And then what series itself? By definition, series is about summation of some ordered sequence as a1 plus a2 plus blah 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 so on until an, which denote with this sigma notation or as Sn. If we take n goes to infinity, then this will be infinite series, generally denoted as this, which the result may be finite, and this finite or infinite result will lead to convergence concept again, but now we have method as convergence test for infinite series. Generally, convergence test has many methods according to the series you're testing. But in physics, there are two mostly used infinite series and its series convergence test. The first one is power series, we denote as an multiplied by x power n as summation, which series convergence test commonly used is ratio test, which like this with the n inequality less than 1 to show that the series converge or not. The next one is Fourier series that denote as this, which is about sin and cos or periodic function when convergence test is choose by yourself. I will take example power series that about Taylor series, which if we have f of x here, which equals to this series expansion, then this equality is valid for only many time differentiable along series convergent region. Next, if we take the first derivative of x and plugging x0, then it equals to a1. And so on with using the derivative rule, we will get that an multiplied by n factorial here is equals to the n derivative of x in x0, which by ratio test, we will get that the interval of convergence is just like this. Again, about convergence guarantee. Fun fact, if you take x0 is equals to 0, then this series will be a Maclaurin series. And if we take the first term is minus index, which for example minus 1 and can be minus infinity, then this series will be a Laurent series. For example, if I expand 1 over 1 minus x function by Taylor series nearby x0 is equals to 0, I will get that any derivative of this function and I apply x0 here is equals to 0, then it equals to n factorial. And our function in series expansion will become as this. And by ratio test, we will get this interval. Now, if I take x equals to 1/2 here, which by function, of course, it's equals to 2, then our series expansion will become as this. And notice that the summation here is a total area in before problem. The first one is squared with area 1, the next one is half area, and the next one is quarter, and so on until n goes to infinity as before about only string line here, which summation of all area equals to 2 by this expansion. And that's why this expansion lead us to geometric series. Now I have three questions. First, what series expansion for multivariable? The second, how about other kind of series? Like maybe about its series expansion, kind of series, the convergence, and etc. And the last one is how we use it in physics. I will take these three for the next video. That's all about introduction to sequence and series and how it's used in geometry and maybe next in physics. I hope you enjoy this video. If you like this video, don't forget to share and subscribe, and see you later.